Right, so today we're going to be working with more geometry review. We're going to be working with 3D solids and a lot of the formulas that you have learned in the past. So I'm going to start off with, can we manage to remember some of our formulas here? So who thinks that maybe, just maybe, you remember volume of a sphere? So, Ron, that is going to be your surface area one. Surface area is going to have square units, so that's where we're going to have the r squared. So hold that for the next line. What do you think for volume? Excellent. 4/3 pi r cubed for volume, 4 pi r squared for surface area. I just hinted at how I remember. Volume has cubic units, so it has r cubed. Surface area has square units, so it has r squared. They both have 4 and pi in them. One has a 3 in the denominator. The one that has the 4/3 has the other 3. One formula gets both of the 3's. The other formula doesn't get any of them. So maybe that helps you guys just a little bit too. Okay, next we are going to move to volume of cylinders or prisms. And I have some models up here to kind of help us with that. Remember that cylinders and prisms are things that look like these two pictures. They have two matching bases, and we can turn those so that those are the top and the bottom of the solid. Does anybody remember when we have a shape like this, the sides go straight up, the top and the bottom match? Do you remember the formula for volume of these sorts of things? Blake. Perfect. Area of the base times the height. We use capital letters, uppercase letters when we're talking about measurements on a solid. So the height of the solid, capital H on there. If we want surface area of one of these, that means we need all of the sides. We need to get the area of all of these and add them all together, including the top and the bottom. So I'm going to have this base. I'm going to have this base. I'm going to have these rectangles around the sides. So if I wanted to get the surface area, it means I need the surface area of what you see me holding here in this model. So how many bases do we have? So we need the area of the two bases, and we need this part around the sides. But when I open it up, what does that part look like? A rectangle. So, and to get the area of a rectangle, we do length times width or base times height, whichever way you've learned the formula. For this one, the height of the rectangle is the very same as the height of the prism, right? The width or the base of this rectangle is the same as the perimeter of that base. So our formula for surface area is 2 bases plus the rectangle, the perimeter of the base times the height. Lateral surface area means don't include the bases, so don't include these 2 bases, just include the perimeter of the base times the height. Okay, next we have volume of a cone or pyramid. So these are shapes that now come up to a point on the top, and they only have one base. So if I took this cone and this cylinder that I'm holding, they have the same base, the same circle, they have the same height. Which one has the bigger volume, the cone or the cylinder? So we can see that the cylinder is bigger. Does anybody remember the relationship? How much smaller is this one or how much bigger is this one? Okay, it would take 3 cones to fill up the cylinder. So the volume is 1/3 the volume of the cylinder. So 1/3 area of the base times the height. Surface area gets a little bit trickier. The base part isn't so bad. We only have one base. So instead of 2 bases, we're just going to have 1 area of the base. But then for the part around the sides, we've got all of these triangles. If we wanted to then take the 1 base plus 1 triangle would be this little b times this h divided by 2, and then I'd have another little b that's the same as that one, and so on. If I put all those together, these little b's all together would make the perimeter again. But it's that times the height and divided by 2, so we're going to have that half in there. And the height of one of the triangles is different from the height of the pyramid. The height of the pyramid or the cone goes from the point down to the middle of the base, but the slant height goes through the middle of one of the triangles, so it's leaning over. So what we're going to have is 1 base plus 1/2 the perimeter of the base times the slant height. And I do pretty well with remembering this formula for the surface area of a cylinder or prism. This one I kind of have to stop and think. It's easy to get the 1 base, so I'm kind of taking half of what I had here. Half of 2 bases is 1 base. This almost looks like I took half of this also. A half of the perimeter of the base times the height, except I've got to use slant height when I get down here. So trying to give you just little hints that might help you be able to remember these formulas. Okay, do not try to memorize these next 2 formulas. All I want you to do is say, well, if it's a cone, I'm going to plug in the formula for the area of the base of a cone, the area of the circle. So I'm going to plug in pi r squared right here. I'm going to plug in the perimeter of the circle or circumference of the circle. If I put 2 pi r in here times 1/2, I just have pi r. If it is a pyramid, I'm going to have the area of the base, but then for the perimeter, I'm going to have all these little triangles. If I had a 5-sided base, a pentagon, I'd have 5 triangles. So I'd have 5 times how long the bottom edge is of one of the triangles. So that's how I'd get the perimeter. I just take 5 times however many sides I had here on the base. So that's it for formulas today. Now we got to start using them. So we're going to switch back to your notes pages. Any questions on any of these? Any of these you aren't sure you got written down correctly? Yes, ma'am. B is one side, one edge of the base. Because it is, we're taking all of these triangles, and so we're getting, it would be the base of one triangle, and if we took that times however many, we'd have the perimeter around that. And again, don't try to memorize formulas 27 and 28. That's just modeling. Oh, you just substitute in to formula 26. Memorize 26. Anything else? Okay, first example problem then. The base of a regular pyramid is a square with each side measuring 4 centimeters. So there's the bottom of our pyramid. So we're talking this kind of pyramid like I have in this model that I'm holding up. Each side of the base is 4 centimeters. And they tell us that the slant height is 5 centimeters. So we want surface area of the pyramid. So we're going to look at our formulas. What was the formula for surface area of a pyramid? Raise your hands who can tell me what the surface area of the pyramid is going to be. So Jemba.
Area of the base plus 1/2 of the perimeter of the base times the slant height.
Perfect. Do we know how to get the area of a square? And Caleb, what do I do for the area of the square? So I'm just going to take length times width, 4 times 4, and I've got 16. What about perimeter of the base? What are we going to get there? We're going to add them all up or take one of them and multiply by how many of them we have, and we get what for the perimeter? So 16, just a little bit different reason. We happen to get the same numbers. They told us slant height is 5. So all we have to do, let's see, 8 times 5 is 40, plus 16. We have 56. Units are centimeters. What kind for surface area? Squared. And we're done with that one. That wasn't bad. Let's try one that's just a little bit more challenging then. Okay, this time we want to get the surface area of a sphere. Okay, that doesn't sound too bad. We've got a formula for surface area of a sphere. And who wants to tell me what the formula for surface area of a sphere is? Lydia. Surface area was what again? The threes have to go together in our formulas. It's either 4/3 pi r cubed or it's 4 pi r squared. So it's going to be squared because it's surface area, so just 4 pi r squared. Thank you, though, for taking that risk. I do that kind of thing all the time, and I'm glad to have the opportunity to reinforce that. So 4 pi r squared. I don't know r. I need r. Only other thing I know is the volume. Do I have a formula for volume that I could write down? So what is my formula for volume going to be, Ian? So volume is 4/3 pi r cubed. I still don't know r, but I know volume. I can substitute in on the left. It doesn't have to always be on the right of a formula. Volume is 288 pi. So if this is 4/3 pi r cubed, I want to use this to get just r. So I need the r's, but I want to get rid of the 4 pi over 3. If I turn that upside down and multiply by 3 over 4 pi, will that get rid of everything except the r's on the right? So I will have r cubed over here on the right. On the left, the pi's will cancel. I think 288 is divisible by 4. Get 72, right? And I believe 3 times 72 will give me 216. What do I have to do to get just r instead of r cubed? What do I need to do? Cubed root of both sides. And if you know the cubed root of 216, tell me. If not, punch it in on your calculator and raise your hand if you can tell me what just 1r would be. And let's see. Hope, what will I get? We will get 6. And I believe these were centimeters, right? So now we can plug that in over here to finish our problem. We have 4 times pi, and then we are going to have times 6 that we need to square. And let's see, 36 times 4 gives me what? So 144 pi square centimeters for surface area. It has pi, so calculator, and then round to 3 places. Lydia, you've got that? Thank you. Great job. 452.389 centimeters squared. And we keep our exact answer and our rounded answers. Everybody good on that one? Okay, I think you're ready for a really, I'll give you an easy one and then I'll give you a much more challenging one. You guys go ahead and do this one on your own. This is just straight, write down the formulas, plug in, simplify, punch it on your calculators. I'll go ahead and hand out tonight's homework set because the next one that we're going to do will be one of the problems actually on the problem set. So, Ian, help me out. What did you get for this numerator? What was 7 cubed times 4? So 1,372 pi over 3. And who's got the calculator value for that? Anybody who hasn't answered yet want to give that a shot? All right, Hope, I know you've answered already, but what'd you get? So there's our volume. And what was 49 times 4? What do we get with that? Ashani, did you get the 49 times 4? So we have 196 pi square centimeters, and calculator answer for that, Lydia? Is everybody comfortable with that one? Okay, next one we're going to do, super messy, number 28. The only reason that this one is super messy is because you have a lot of parts on it. You need to get the volume of this thing. You need to get the surface area of this thing. And then you need to get the volume of this cone. And I want to point out something about this book and the vocabulary that it uses. Up to now, when it says cylinder in our Saxon books, it means something that has two bases that are both circles. The Green Book doesn't use cylinder that way. It still has to have sides that go straight up and down, but the base can have any combination of curves and straight edges that you want to have. It does not have to be a circle. But they are saying with that, this is the top and the bottom, and the sides go straight up and down. Is everybody okay with that? It's a little bit different definition than you're used to for cylinder. So, if sides go straight up and down on this shape, what is our formula for volume going to be? Anything with sides that go straight up and down, what's your basic formula going to be? Ryan? Area of the base times the height. Since we have so many things to fit in one little box, we need to plan our space carefully. So we're going to write down volume, and I'm going to label it, since I have two volumes in this problem, the cylinder, not the cone, is area of the base times the height. So now I need to get the area of this weird shape over here, but I know I have missed lots of problems when I have something long like that, because then I forget to write the height at the end of it. I'm going to go ahead and write down height times the area of the base. So I'm going to go ahead and put 9 for the height times the area of the base, so I don't forget the 9 at the end. Okay, I need some help. How do I get the area of this base? This is a problem from Algebra 1. How do I get the area of the base? It's got a bunch of different little parts in there. Mia. Okay, so help me start doing that. You want to do the semicircles or the rectangle first? Okay, what's the area of the rectangle going to be? Be real careful. This is 11. How tall is this? So that's going to be 11 times 10, or 110 for that. This is 5, this is 5 for the height. Okay, then I've got semicircles. What's the formula for the area of a whole circle? Pi r squared, so I'm going to need pi r squared divided by 2 for a semicircle, right? So I'm going to have, for the big one, what's its radius? So I'm going to have pi times 10 squared over 2, and pi times 5 squared over 2, and all of that's going to be added up and multiplied by 9. We need to simplify as far as we can, keeping pi as pi. So we have 9 times 110, And then, yes, 100 pi over 2 is 50 pi. But if I want to put that together with 25 pi over 2, I need the common denominator. So 100 pi over 2 plus 25 pi over 2 gives me 125 pi over 2. Then I need to distribute the 9. So I have 990 plus 9 times 5 is 45, 18 and 4 is 22, 1125 pi over 2. Volume is cubic units, and I need calculator help here. Jimbo, what do you have?
27.
So 2,757.146 centimeters cubed for the volume of the cylinder. So far, so good? And actually, this was the exact value of it, so I'll put boxes around both of those. Okay, now let's do surface area. Surface area, when the sides go straight up and down, how many bases do we have?
2.
So we need twice the area of the base plus, what's the rest of the formula?
Perimeter of the base times the height.
Very good, perimeter of the base times the height. Now, I don't want to repeat a lot of work if I don't have to. Volume of the cylinder was area of the base times the height. So it was 9 times the area of the base. Isn't this part in the parentheses the complete area of the base? So I am just going to repeat that work over here, and I'm going to use an exact value, 110 plus 125 pi over 2. Plus perimeter of the base times the height. Once again, I don't want to forget my height, so I'm going to write it down first. And now I need the perimeter of the base. So Callum, help me get the perimeter of this base, please. Okay, so we've got the straight pieces giving us 32, and circumference of a semicircle, so half of a circumference. What's my circumference formula again? Pi d or 2 pi r. If I take half of 2 pi r, what do I have? Pi r. So what's the radius of the big one?
10 pi.
So the radius is 10, so pi times the radius is 10 pi. And then for the small one, it is going to be plus 5 pi. And there's my perimeter. Simplify as much as I can. Pi is still pi. 220 plus 125 pi, if I distribute this 2, plus 9 times 2 is 18, 27 and 1 is 28, and 15 pi times 9 is 135 pi. Does that work? Did I get that right? 15 pi, and I'm distributing the 9. The 32 came from 11 plus 11 plus 10. I find it helpful to highlight, not in the book obviously, draw a quick sketch, and I can kind of highlight, have I used all the pieces to make sure I got all the parts in there? Then I need to put like terms together, which means, let's see, for the pi's I have 260 pi. And the regular constants, I have 508. That's my surface area, so units are centimeters squared. And calculator will give me what here? Lydia? And that was my surface area. Okay, almost done. We've actually done the long parts. Now we need volume of the cone. What is the formula for the volume of any cone?
Uh, the area of the base times the height divided by 3.
1/3 area of the base times the height. Have we not already found area of the base times the height?
Yep.
So what we are going to do is to take the exact answer. We're not going to reuse a rounded number. We're going to take 1/3 times the 990 plus 1,125 pi over 2. We are going to distribute the 1/3. So this part's easy, 330. 1125 is divisible by 3. 3 goes into 11 3 times, into 22 7 times, into 15 5 times. So this volume is 330 plus 375 pi over 2 cubic centimeters. And punch that in on your calculators. And Mia, do you have it? Excellent. Thank you so much. So long and messy, but we got there.